of AB length. One end is fixed and other end is having a spring. The spring consists of a cantilever and one end is fixed, other end is fixed. Now a mass is being applied at the end. As shown in figure, form the equation of motion and find the expression for equation of motion. Now in previous class I have discussed with you the equation of motion. This is the general solution and this is called equation of motion. How to find it? X naught cos omega nt plus x naught dot divided by omega n sin omega nt. This is the general solution which we will be using in this problem. For writing equation of motion, you need mass constant and stiffness. Both the constants are required. Stiffness K1. Let us take this as K1. K1 equal to 3EI by L cube. You know that stiffness of a cantilever beam. If you find the stiffness here, the mass is supported by two stiffness. What you can do is you can add K1 plus K2. This 3EI by L cube is K1 and stiffness K1 equal to K1 plus K. This is given as K and this is a cantilever beam. How to find stiffness for a cantilever beam is the formula 3EI by L cube, and instead of K1 you can substitute 3EI by L cube. If you substitute instead of K1 this component, you will be getting L cube as the denominator, and you can make common denominator as L cube and you can multiply KL cube. Your effective stiffness KE equal to 3EI plus K L cube by L3. Now both the components became K. This is known as effective stiffness. Then differential equation of motion. Know that this is mx double dot plus kx equal to 0, which I have discussed in previous class. You know this, you have this kind of system, a stiffness and a mass. For this system, you know the general equilibrium equation is mx double dot plus kx dot equal to 0. Why minus is written here is both the components are acting left hand side and hence both the components are taken as negative here. So you can commonly take out negative mx double dot plus kx dot, and if you substitute minus to all the components of this equation, you can cancel it. So your general equation will be mx double dot plus kx. Now in this formula you have mass, they have given as m, and x double dot is kept as it is. K is known as effective stiffness in the current problem. You have to find the effective stiffness, that is Ke. You have already found out, then you will be substituting in this equation. Now the equation of motion will be like this: mx double dot plus kx equal to 0. This is your equation of motion. Now you can take it Ke outside. Instead of Ke, you can substitute, currently you have found out 3EI plus KL cube by L cube. Substituting here, and your general solution will be like this. Now what is the second component? Find the expression for the frequency of motion. You have to find frequency. What is frequency? Root of K by M. K now is called the effective stiffness. So substitute the effective stiffness in the solution, you will be getting the answer. Root of Ke by M. Ke is already known here. You substitute Ke. How to find frequency is, you can find it by dividing 2 pi. Omega n equal to 2 pi into f. So you can cross multiply 2 pi here and you will be getting the solution. So this is your frequency of vibration and this is the differential equation motion. Here you have the value of stiffness, also the value of mass. Find the natural frequency of the system as shown in figure. Take K1, K2 equal to 2000 Newton per meter. K3 is 3000 Newton per meter and mass as 10 kg. This is called the system and they have given. You have to make this component into a single parameter. This is K1 and K2. If the two stiffness are parallel, how you can find effective stiffness? K1 plus K2 you can add. If it is parallel, you have to add K1 plus K2. Then if your system is like this, if your K1 is 2000, K2 is 2000, you can add these two parameters and write it as 4000. So your Ke will be 4000, mass is given, below that you have K3. Now your system is like a series connection. For a series connection, you have to find 1 by Ke1 plus 1 by Ke plus 1 by K3. You have this component here and this is called K effective. You can find both the K effective. The two springs K1 plus K2 are in parallel, hence you can add both the components and write it as K effective, Ke1. It will be 4000 Newton per meter. You know that if a spring is parallel, you have to add that. The value of a single spring is 2000 and both the springs will be 2000 plus 2000. So your K effective will be 4000 here. This is first spring. And second spring will be the bottom part called K3. If it is refined like this, you have found out Ke. If Ke1 is found and your system is like this, now you can make into a single system by using this equation Ke divided by 1 by Ke1 plus 1 by K3. This is Ke1 and K3. You have to inverse this. You know Ke1 is 4000 and K3 is 3000. You can substitute K3 as 3000. You will be getting Ke. It is 1 by Ke. You will be getting this answer if you divide these two components and inverse this, you will be getting Ke. Now Ke is 14128. Now you know frequency. What is frequency? Root of K by M. So you have to root this K effective by M. Mass is known as 10 kg. The answer will be 37.57 radian per second. Omega n is this root of K by M. A simply supported rectangular beam has a span of 1 meter. So this is 1 meter. You have the cross section of 100 mm wide and 10 mm deep. The cross section is given. This is 10 mm deep. It is connected to a midspan of beam by means of a linear spring. So if a beam is connected with a spring at the center, okay, this carries a stiffness K equal to 100 kg per centimeter. They have given it is connected in a beam which is having linear spring, stiffness of 100 kg centimeter, mass of 30 kg. It is attached to the other end of the spring. Determine the natural frequency. Now, how many springs are connected? You have one spring. This is called, take it as K1, and this beam. Beam is also a flexural member. If you are adding any load, what happens? It bends. It provides a stiffness parameter. What I said in last class, what do you mean by stiffness is, you are having a cantilever beam. If any force is provided, it will deflect. So stiffness, how to find the stiffness? Force divided by the displacement. So how much force is required to make the displacement is known as stiffness. Same way you have a beam here. If I am providing a mass, this beam becomes a stiffness member, and this is stiffness called Kb. What do you mean by Kb is beam stiffness. K stands for stiffness, B stands for beam. So beam stiffness, both are connected in series. So this is connected, and below that you have a connection called K1. Now you have Kb and K1. Now you know to find Ke. How to find Ke? 1 by Ke equals 1 by Kb plus 1 by K1. K1 is directly given as 100 kg per centimeter. Note that stiffness always you have to substitute in terms of Newton per meter. It is given kg per centimeter. How to convert this? Kg to Newton into 9.81. Then you have to make centimeter to meter. Now you have to divide the component divided by 100. So you will be getting Newton per meter. The same way you have a formula how to find stiffness for a cantilever beam. In last problem 3EI by L cube you have used. Now if you need stiffness for a simply supported beam, take down this as the formula 48 EI divided by L cube. Two types of beam they can ask. One is a cantilever beam, another one is a simply supported beam. If it is simply supported beam, how to find K? 48 EI by L cube. Now you can substitute the parameter. How to find Young's modulus? They have given in terms of 2.1 into 10 power 6 kg per centimeter square. Note that you have to convert in terms of Newton per millimeter. How will you convert this? 2.1 into 10 power 6 into 10. Now it will be in terms of Newton, then divided by 100. 10 and 100 will get cancelled. You have to divide it by 10. Your answer will be 2.1 into 10 power 5 Newton per millimeter square. Now that is the value for E. Now how to calculate I? I is moment of inertia. What is the cross section of the beam? You have only longitudinal section. But they have said that the beam is 100 mm wide and 10 mm deep. So your width is 100 and depth is 10. How will you find for a rectangle? BD cube by 12. Now your breadth is 100, depth is 10. So 100 into 10 cube divided by 12. You will be getting I. Now what is your overall length? Length is 1 meter. The stiffness of simply supported beam is KB 48 EI divided by L cube. Now you can find it by I equal to BD cube by 12. So your breadth is 100 and depth is 10. Here it is substituted in terms of centimeters. 100 millimeter is 10 centimeter. 10 millimeter is 1 centimeter. Divided by 12, you will be getting I in terms of centimeter power 4. Now, how to find KB? 48 EI, they have taken it as 2.1 into 10 power 6 and I is taken as 0.833 divided by 100. This is L cube. So length is 50 plus 50 equal to 100 centimeter. So your KB will be getting in terms of kg per centimeter. KB will be in terms of 84 kg per centimeter. You have this value. Then if this is your case, your beam is like this, you have one number of stiffness and below that another stiffener is connected. So your system will be like this, one below the other. This is in series connection. So what is KB? KB is stiffness of beam, beam stiffness. K1 is stiffness given in the problem called 100 kg per centimeter. So you have to divide this. 1 by KB is 84, 1 by K1 is 100. What will be your answer? You got 45.65 kg per centimeter. You got this value? And check that before substituting in terms of frequency, that is omega n, the K value should be in terms of what? Newton per meter only. Note that K value is in terms of kg per centimeter. Now you have to convert in terms of Newton per meter. How to convert? Kg into 9.81 and centimeter to meter into 100. So you will be getting 981. You multiply, you will be getting 0.448 into 10 power 5 Newton per meter. Now if you substitute this, you will be getting 12.22 radian per second.